Hello everyone, welcome to Study and Travel YouTube channel. Today we are going to talk about some research topics, mostly for the students. They are looking for a research proposal in their field, or they are looking for some topics that they need to make some research proposals on for their admissions in masters and PhDs. Whatever, why I need to record this video is I found many students, they are struggling, they keep on asking about the research proposals or a sample of a research proposal. So if you're really looking for a research proposal sample, I would recommend you, I will suggest you do not look for that, and try to find out yourself, and you will find many topics around, and then from those topics you can see what is the area that interests you the most, and according to that you can find your topic. So here I come here with a paper named is a real-time active detection of targets and path planning using UAVs. So you know that, and this paper is actually presented in 2021 IEEE International Conference in Robotics. Uh, so you know that the UAVs is unmanned aerial vehicles. They are the applications are everywhere. If you see that the uh, they are used in industrial scenarios. They also used to detect defects and capture data photographs in dangerous environments. If there is a fire or there is some other issue, there's an accident, and there's a blast. So UAVs are very useful. That they also used to monitor the industrial plants and the systems. Nowadays, they are also being used for the delivery of the required payloads. If your machinery or some medicine is required, so they can carry the UAVs can carry the payloads and then uh, deliver to the right position. They are also used for the delivery services as well. Uh, but we are more concerned about, according to this paper, we are more concerned about the power distribution lines monitoring and defect detections. So this is the scenario where you can see that you have transmission lines, and transmission lines can be anywhere. It can be on mountainous areas, it can be on very difficult places, on heights where the main force is not that capable to go because it's too risky. So normally UAVs can perform a much better task, and they can go up with thermal cameras, with lidars, uh, and then they actually gather data and images, and from there you can classify the different status of different components of the transmission lines. So this is a good area where people are working on. You see that the main slide is monitoring power transmission lines using UAVs. So traditionally, workers need to travel through mountains and rivers for inspection. So it's very costly and time consuming. But if you have a drone, you just need to fly it autonomously, can avoid lots of obstacles, and it can find targets very easily. Apart from this, it is very intelligent in image capturing and data processing, and but the big problem in this uh, task, that the battery life is very limited. So we need the optimized path, as well as we need to capture photographs very fast, very rapidly. So according to this paper, the objectives of this paper are uh, find a target in unknown environment, identify the target, capture photographs, avoid obstacles, and optimize the shortest route. But owing to limited UAV's computing capability, point cloud data of the surround objects obtained, perform semantic segmentations on data, semantic data merged into voxels, Euclidean sign distance fields is used to reconstruct the distance and the angle of the obstacles, adjust the gimbal or a gimbal angle and focal length, 2D image recognition techniques used to shoot photographs of the target. So these are actually the key points of this paper, this research paper, and this research. So if you're very interested into it, you need to go into the details of everything. You know that the point cloud data is a data which is captured by a lidar, where you mark different points on the surface, and you get the, you know, along to the x y z axis you get different points, and these points actually represent certain data. So if you go ahead, actually this is actually the proposed method. Here you can see the lidar mapping and modeling. So it's a real-time point cloud segmentation and TSDF reconstruction with semantics. So what is it is doing, lidar is actually mapping a certain area, and then because lidar is throwing the light and getting some reflection from there, so it gets the data points. So it's a different streams of lidar touching the grounds and then coming back with certain information. So from there they actually reconstruct the environment in a 3D or 3D environment, and then from there you can see that in 3D environment, once we talk about 3D, it talks about voxel extraction. So from there, if you get a segmented, if you get a reconstructed with semantics, semantics are actually the samples, or then from there you can actually do the path planning, and then uh, multi-planning, multi-tower planning, or single tower planning, and so on and so forth, and you reach at the target acquisition. So this is actually the algorithm they used. In other ways, like it's point cloud data of the surrounding objects, then they do the segmentation methods, then the semantic attributes merge into the voxels, and then they reconstruct uh, distance and angle, and then 2D recognition, 2D image recognition to shoot. So if you go ahead, uh, then you see it's like something like that. Real-time 3D point cloud data can be quickly segmented and voxelized, enabling the UVs to avoid obstacles and actively shoot the targets. So somehow, uh, after the uh, lidar point cloud data, you can find something like that. You see it actually reconstructed the real uh, environment into something into the 3D. So so and then it also uses a in this paper they use a Rendla neat and efficient neural architecture performs the task. So it's the algorithm they use here. And so what is semantic segmentations that you need to use, that they are using actually. So you need to look into it, uh, into the deep, if you're really interested into it, because semantic segmentation is a deep learning algorithm that associates a label or category with every pixel on an image. It is used to recognize a collection of pixels that form distinct categories. So if you're interested in this, my mission is not to explain each and everything, but my mission is just to make you introduced to different such areas where you might be interested in. So uh, along with this, the slides actually tells the path planning, and you see from the different angles and from different heights and different sides. And they also tested this method on with 4 experiments were performed: point cloud accuracy verification experiment, point cloud segmentation performance verification, UV path planning flight test, and also photo shooting accuracy verification experiments. So they validate their model and experiment on these tests. So they have the data sets here actually. So the first city is like have these attributes. This city is 20.3 length, number of power towers is 61, number of blocks this one, and so on so forth. So this is the data set. So city 1 and city 2. So what they do is for the city 1 they actually train the model, and for the city 2 they actually test it. So you know that if you're familiar with the machine learning, you are very familiar that machine learning uh, needs to be machine learning algorithm needs to be trained first, and then uh, you can apply a different data set to test it, and how efficient it is, so you can actually know after testing. So they also have a video you can see on the YouTube. I can show some part of it to you. So you see they have a small airports, and which have a mechanism where they change the batteries and also install the cameras. So if you are going to the site areas and you want to really inspect, you want to start an inspection operation, so what you need to do is just you need to have a mobile airport from where your drone will fly, and follow a certain path you can see in this video as well. So uh, they are actually detecting different insulators in the transmission line and capturing their photos, and by this way they can actually recognize using the machine learning algorithm the condition of different insulators on different heights of the tower. So that's it. If you're interested into this field, you can go through this paper, real-time active detection of targets and path planning using UAVs, and give some time to this paper. It's a very good paper, and once you finish it up, uh, you can read more in uh, the recent paper as well. So thank you so much. Thank you so much.